Hello, my name is Rob Ulfig, and I'd like to introduce you to a new tool in the toolbox of atom probe tomography data analysis, the peak identification tool. Atom probes now come with a sophisticated suite of control and real-time data tracking software, and these programs continue to add useful features. The software has moved in a direction where each of the distinct programs that APT users are familiar with have come together under a new program called AP Suite. With our initial release of AP Suite 6, we have not yet incorporated the ACC program, but the others, Davis, ISDB, and IVIS, have been brought into modules within AP Suite that also include a custom analysis interface to use third-party code created by the Atom Probe community. New systems have been shipping with AP Suite, and existing installations are being migrated to the new platform. If you are under warranty or service contract, you'll have the opportunity to upgrade to this all-inclusive program soon, and it comes with some great new capabilities. Today we'll discuss an important feature, the mass spectral peak identification tool. The peak identification tool requires a well-calibrated mass spectrum. Use the automated time-of-flight calibration tool. It's now more stable than ever, using up to 3 peaks to maximize spectral quality. So it will use the whole spectrum, not just a single peak. Punch the start button, and like a monkey, let it finish. Mass calibration requires a bit more thought. Use the default linearization calibration, choosing 3 to 5 widely spaced peaks that have good statistics, meaning lots of counts. Identifying more peaks is fine, but there are diminishing benefits. Don't use hydrogen peaks unless absolutely necessary, as these gas ions have more timing variability. Choose only peaks you are certain of, and when analyzing from a family of similar datasets, choose the exact same peaks for each analysis. This will make ranging and peak finding more consistent. Also be aware, some peaks may have already been calibrated during data acquisition in the new live calibration of the Davis module. Remember, all 3D spatial information and subsequent data analysis relies on ranging. Be sure you do a good job. The new Peak ID tool can help you with simple or complicated spectra. Let's take a look at how it works. The Auto Peak ID function measures the background and identifies the peaks with lower and upper limits and a maximum bin value. There are a variety of variables exposed that may optimize peak finding depending on spectral quality. See the user manual for descriptions which will help you optimize the peak finding for the materials you analyze most. There are a lot of matrix math involved, and we won't cover that here. I'm not sure I could cover the math properly anywhere, but using a Bayesian statistical method, possible components are turned into models and are compared to the measured data in a complex scoring method is then used to rank the possibilities. The user then chooses the peaks that make sense using the algorithm suggestions and their own knowledge of the specimen they're analyzing. The search can be applied to the entire mass spectrum or just the window you're viewing in the event you're just tracking down some pesky unknowns. Initial peak confirmations are fed back into the model to improve the scoring method and iteratively improve the rankings. It's really cool. The newly identified peaks can be applied to the existing mass spectrum, and this process includes the option of overwriting the previous ranging or just adding newly found peaks. Ranging is often done in 2 or more cycles. The green path in this flowchart is the second round. Peak ID is a great tool to use in each round, but use your brain too. Remember, the peaks you identify will be used to modify the algorithm and make it smarter. The point of this slide is to remember to use 3D information to help quantify unknown peaks. In this example, a confusing peak at 60 Daltons was found to be in the same 3D space as oxygen at 16 and 32. So a bit of thought, and we can see that silicon at 28 plus molecular oxygen at 32 identifies SiO2 at 60. So that 3D knowledge is really important. Here's an example of the auto peak ID list for a gallium nitride material. You can see there are certainly many nonsensical combinations in the suggested peak ID list, but in this case, there's a clearly identified ion, gallium silicon nitrogen. It's clearly present at the right ratios. Maybe with a bit of luck, I could have guessed this relatively complicated identification, but likely not. Peak ID works, and it works hard, so you can concentrate on other things that are more important in the analysis process. Peak ID is a new feature with lots of options. Look for a future webinar at atomprobe.com that will delve into the processes and options to give you the best results. In the meantime, please use it and give us feedback so we can continue providing the community with the tools you need to do your work efficiently. I always enjoy thanking my team of coworkers, many of which who've been working together for almost 20 years. Be sure to visit atomprobe.com for a wealth of information, and of course feel free to send any questions you have to me or through our applications question ticket-based system found on the website. Thank you.